Okay, isn't that a pretty rose curve that we just drew without recording? All right, so here we go. Now we're going to take this polar equation and convert it to rectangular. Okay, so here we go. This is number 4. Whoops. Here's my equation. R is equal to 2 cosine theta?
Yes. Plus 4 sine.
4 sine theta. Remember our conversions that we had on our, well, I think they're at the top of your notes page, but we wrote them down. Okay. I want to multiply both sides by r so that I have an r squared equals. Okay, so let's do that first. Multiply both sides by r, and I'm going to make myself a note here that that's what I'm doing. Multiply both sides by r. All right, when we do that, we get what? R squared is equal to 2 r cosine theta plus 4r sine theta. So far, so good? Okay, didn't we say that r squared is equal to x squared plus y squared?
Yes.
Okay, so I'm going to change that r squared to x squared plus y squared equals, didn't we say r cosine theta was what x is equal to? All right, so I can change this to 2x plus, what is r sine theta? Plus 4y. You have just converted this to a rectangular equation. Your r and theta have gone away, and you've introduced x and y. Here's the thing. If this were free response, right here is your safe stop. Make that note. Safe stop if FRQ. If FRQ. Yes, ma'am.
I'm just warning you, there's no water pressure, and when that happens, they make us go outside for like so just
Make us go outside for what?
like an evacuation thing.
Oh.
So just be prepared. I'm hoping they get it fixed, but I'm just letting you know
Okay,
that happens.
that might happen. Okay, well, I've got a jacket today.
All right.
All right, guys, here's the thing.
Stay locked in, y'all.
If this were multiple choice, they would probably complete the square and see what conic section this actually was. Yeah. So let's complete the square just so that we can get that back in this part of our memory rather than way back here, because it's probably been a minute. Do y'all remember when we complete the square?
Kind of, sort of.
That's okay. That's all right. So I need to get my x's and y's and x squares, y squares all together, okay, and constants on the other side. Well, I'm looking at this, and I don't have any constants left, or yet, okay? So I need to move both of these to the other side. So this gives me what? X squared minus 2x. Completing the square, remember you're going to create a new c value. Ax squared plus bx plus c, okay? Okay, I'm going to also move this over. Plus y squared minus 4y plus some new c value. Well, instead of equal to 0, it's going to be equal to whatever I just added to the other side, right? If you add it to one side, you got to add it to the other. What we're trying to do is create a perfect square trinomial that will become a binomial squared. Okay, do y'all remember how to get that c value here? You divide this by 2 and then square it. So what would this be? 1. So add it to the other side too. Divide this by 2 and square it. What do you get? Positive 4. 4. All right, so then this trinomial right here is what binomial squared? X what? Minus 1 plus, what about this one? Y equals, what's that an equation of? A circle centered at 1, 2. Radius is square root 5. Yeah, this is r squared. Awesome. That was fun. Okay, we have one more. Problem number 5. I'm going to do this on another page. This is going to take a little bit of room on this one, okay? Number 5 says, find dy dx for the equation r equals sine theta. For 0 to pi. And then it wants all the points of horizontal and vertical tangents. So dy dx, and you've got a polar curve. Well, dy dx is still the slope of the curve, a slope on the curve of this polar graph, okay? So write this down. Slope of a polar curve is still slope of the tangent, which is dy dx. All right. Well, we know that x is equal to r cosine, right? And y is equal to r sine. Okay, well, let's plug that in. Here's your r. Your r is sine, yes? So if x is equal to r cosine theta, you've got your r. It's right there. So then x is equal to sine theta cosine theta. We good? I'm just plugging in what r is. R is sine theta. So I'm replacing that r with sine theta. We good?
Why are you just putting the cosine over there?
Pardon me?
Like, why are you multiplying that by cosine?
Because r is sine theta. So I replaced this r with sine. So instead of x equals r cosine, I replaced that r with sine theta times cosine. Because there's a cosine right here. We can't get rid of it. Okay? Because this r cosine is exactly what x is equal to. And we know what r is. Okay, so we also know that y is equal to r sine theta. So then y would equal, what are we going to place in?
Sine squared.
Yeah, it would just be sine squared theta. So now guess what we need to find? We need to find dx d theta and dy d theta, and then put dy d theta over dx d theta, and what do you end up with? Dy dx, just like we did with parametrics, only now it's theta because it's a polar curve. Okay? All right, what have you got going on here to derive? Product rule. Well, you got chain rule, right? Because the sine, you got to pull the 2 down, and then the derivative of sine, right? Okay, so here we go. Work this out with me. Dx d theta is equal to derivative of the first times the second, so cosine squared, plus the first times the derivative of the second. That will give me negative sine squared. Ooh, trig identity. What is cosine squared minus sine squared? That's one of the things that cosine 2 theta is equal to. I would change that because that's going to make this one easier to work with. Cosine 2 theta. You don't have to. It's just going to make it easier to work with. All right, so let's find dy d theta. We're going to pull the 2 down. I could rewrite this if this makes it easier. Sine of theta squared, right? So pull the 2 down times sine theta, and then the derivative of sine is cosine. Ooh, trig identity. What's that? Isn't 2 sine cosine sine of 2 theta? All right, so then dy dx is going to be dy d theta over dx d theta, right? So then dy dx is equal to sine 2 theta over cosine 2 theta. Where are your horizontal tangents going to be at? Are they going to be when this is equal to 0 or when this is equal to 0? Top or bottom? Top. It's going to be when your dy dx is equal to 0. You're going to have horizontal tangents, right? Okay. What are you going to have when this bottom is equal to 0? Vertical tangents. Okay. All right. So let's set each of these equal to 0 and find out. Here's the problem. You may get a long list for each of them. We won't get too long because we're only going 0 to pi. Yeah. Okay. So you're going to get maybe 3 or 4 solutions for each of them. Horizontal tangents are when this is equal to 0. Vertical are when this is equal to 0. Here's the thing. If you have a theta where both of them are equal to 0 at that same theta, it's inconclusive. We don't know if it's a horizontal or vertical, so you cannot include that. Okay, so plug and chuck. I want y'all to give me those thetas where those are each equal to 0, and I want to know where horizontal and where vertical tangents are. Ready, go. Talk to each other. See if you end up with the same thing.
No, that's not in the thing.
So I got 0 pi and pi over 2 for the first one.
So it would be, have to be pi over
For
4.
cosine, I have pi over 4 plus 3 pi over 4.
That's just pi. Is it 0 to pi or 0 to 2 pi?
0 to pi, but both of those are less than pi.
And 3 pi over 2.
What about for the cosine? Wait, why is
And you multiply that by the 2.
his sine, or 2 times 0 is 0.
And what else?
Sine of 0 is 0.
I think that's it.
I thought we were talking about cosines.
Yeah, because it's just over 4 from this.
Pi over 4 and
Oh yeah, that was good.
0 another
And
one.
then that is
Half up station.
what I was trying to figure out.
I want my fish right
Happy birthday, guys. You know it was Session's birthday yesterday?
now. Yeah, I figured out.
I figured out and hey, Miss Grace said, did Session?
Yeah. You'd like me on another day.
Session was like, Miss Grace said, please.
Yeah.
Okay, guys, so this has 2 stars by it, so it came from an FRQ. Is that enough work for my FRQ? For my final answer? Probably not. I would need to say horizontal tangents occur at. Now, what did they ask for? Did they ask for theta values or points? They asked for points, so they want those polar coordinates. We want r comma theta. You got your thetas here. How are you going to get your r?
Plug it back in.
Plug it back in, into what?
The first equation.
Yeah, that right there. You're going to plug those thetas back into this equation to get your r for that theta. So then my final answer would say horizontal tangents occur at, what's my first polar coordinate? 0, 0, good. And I didn't even go back and check this. We don't have any matching thetas here. So there's nothing I'm going to cross off because they both equal 0, right? Okay. So what's my next polar coordinate? Yep. And then where? 0 pi. And then vertical tangents. Occur at pi over 4. What's the sign of pi over 4? There you go. Root 2 over 2, comma, pi over 4. And 3 pi over 4. That's it. Beautiful. What do you think? Okay, I would get out that purple polar graph help sheet to help you through the Delta Math, okay? The Delta Math, I think there's 5 problems on there, and you are actually sketching the curve on Delta Math, okay, on all of the equations. No, that's what I said. We're going to omit number 6. Yeah.
She like, did I understand it? I think it does. We'll see what happens. I've got that before.
We graphed our notes. We graphed a rose curve. I believe Delta Math has only limicons, okay, but at least you got to graph a rose curve in our notes today, okay. So this should allow you to start working on those first 3 math test problems, right? That are polar problems.
We have to start my test today, right? Yes.
Yeah, let's take a look at this test one.
I wrote you copies of your answer now.
Yeah, I mean,
Tomorrow we are regionals.
Wait, I get it now.
Miss Lee,
Yeah,
I'm
baby.
not going to be here tomorrow.
Oh,
We
okay.
have regionals for Sun, so.
Okay, I promise I will remember to record it tomorrow.